and today we're in Kidstown at the Michigan Science Center. And part of our Fizz science demonstrations, today we're going to be learning about acids and bases. Now to test this, we're going to use water and something called a universal indicator. So I'm going to pour the water in my beaker, a little too much. Then we're going to add the indicator, and what this does is it changes depending on what level of pH is in whatever we're testing. So as you can see, it didn't change color, it's still green, so that means our water is neutral. Now, our experiment is we're going to see if it turns into an acid or a base based on just me blowing into it with this straw. And if it's an acid, it'll get a lighter color, and if it's a base, it'll turn to a darker color. So let's see what happens. Alright, so as you can see, it got a little lighter, and that means that the carbon dioxide that I was putting into the water caused it to turn to an acid. Now you can repeat this experiment at home in a different kind of way. You can use something called red cabbage, and you boil it down in water, and you can make your own pH indicator. Hi, my name is Sarah, and today at the Michigan Science Center we are going to be doing an experiment with pH to see whether these household liquids are acids or bases. And what pH is that means the potential of hydrogen. And what we're going to be using today to detect the pH is something you might have at home. It's called red cabbage, and this is what it looks like. What you do is you put it in water and boil it until the water turns into a purpley blue color, just like this. And if we were to look at our scale here, this is how we're going to see what our pHs are. It ranges in colors and numbers, but to make it easier, we're just going to look at the colors. So since this is just water in here, our first liquid we're going to test is water. And we're not going to get much of a color change, so that just means it's neutral, even though it's not the same color as on our scale. Right? The next one we're going to test is Windex, which is a window cleaner. That's green, that's basic. Next we're going to test our lemon juice. It's turning a reddish color. That means it's an acid. Next is baking soda mixed with water. That's another basic, it's nice and green. Next is orange juice. Ooh, that turns red too, that means it's an acid. And finally we have our vinegar. And again, we have another acid. So you can test all of the household liquids you have at home to see if they're acids and bases. And you can also combine them to see what happens when you mix acids and bases together.
Hi guys, I'm Osama. I'm an educator here at the Michigan Science Center, and we're going to learn a little bit about pH, which is a term you might have heard everywhere quite a bit. And it's just a fancy way that scientists like to say potential of hydrogen, which is basically how we measure how acidic or how basic something is. It's basically how many hydrogen ions are there or how little hydrogen ions are there. So the more acidic something is, the more hydrogen ions that we have, and the less acidic that it is, the less hydrogen ions that we have. So everything around us has a pH level, whether it's the table or the water or our skin or our bloodstream. And if you've been paying attention in science class, then you should know that even normal tap water has a pH, and when you're measuring pH, which is from like a 1 to a 14, you should go right in the middle somewhere, so it's around a 7. So what we have here to help us identify what the pH is of the water is universal indicating solution. And it basically gives us a little bit of a color code. And it helps us know how acidic or how basic something is. So I'm going to start dropping in here a whole bunch of solution, because we've got a lot of water in here, until it turns a nice shade of green. And give it a nice here scientific mix. Now this indicating solution loves to indicate from blue all the way to red, and green is somewhere in the middle. So what I said earlier, and we could look at it against my white coat over here, is that this is supposed to be neutral pH, which is what this indicating solution is telling us. But if we take something that's really basic, so it has a lot less hydrogen ions than water does, and in this case we have ammonia, which is some really unpleasant stuff, and we start dropping some of that in there. Now ammonia is really basic, so it shouldn't take too many drops. And I'm going to start mixing it a little bit here. And as it's mixing, we could see it actually turning from that green to a shade of blue. But that's not good enough for us. Now, you guys may have heard of some dry ice, which is actually the solid form of carbon dioxide. And dry ice actually burns when we hold it with our bare hands, so that's why I'm wearing these gloves. But when dry ice, or carbon dioxide, is put into water, it mixes and it creates a substance called carbonic acid. Now, if you're paying attention to the name, it says acid, so we should get a nice color change that tells us this is acidic. So I'm just going to drop all my dry ice in here, and if we look at it, it's turning yellow and slowly to red. And we can see that the water is turning into that carbonic acid, and our pH indicator is indicating that there's a lot more hydrogen ions inside the water. And that is a demonstration of pH.